All right, with that, would love to introduce Magazaki with Qualcomm Technologies. First, maybe you can start by introducing yourself and what you're working on now at Qualcomm. So with that.
Sure, yeah. So this, I don't know if you can hear me okay?
Tilt a little towards you.
Okay. Okay, can you hear me okay now? Yeah, 1, 2, 3, okay. So this is Magid Zaki. I'm Director of Corporate Technical Marketing at Qualcomm. What I have been focusing on for actually almost the last year is some work that we are doing in these cognitive technologies that we're going to be defining today. My team in general looking into different technologies that will be important in the next 1 to 5 years. So you can imagine we are working in 5G, LTE-U, LTE Direct, many other technologies. But people are not familiar enough what we are doing on the mobile computing side and things related to machine learning and computer vision. And that's what I would like to talk to you about a little bit more today.
Can everyone hear Magid okay? Seems a little bit low, so... Nah, all right, a little louder.
Louder, okay.
No feedback yet. Anyway, it's substance rich. I want to make sure everything comes through, so...
Okay.
So thank you for that introduction. I thought maybe a good place to start would be when you say cognitive technologies, what are you referring to? So
So actually, what do we mean by cognitive technologies and why cognitive technologies? So basically, as we are working on the wireless and mobile computing and IoT, there are basically two main components that go into that. One is related to connectivity and wireless, that again we work on a lot. And then the other one is relating to adding basically...
I'm sorry, that was giving me too much feedback.
Yeah.
Okay, so mute your...
Yeah.
Mute it.
Am I better now? Or?
There we go.
Okay. So then the other aspect is adding intelligence to these devices. And adding intelligence is through basically adding another layer of machine learning and doing interesting stuff. And the main point behind that, or why we are doing that, is we feel many of the emerging devices, including smartphone, but also IoT devices, robotics, cars, would need basically to deal with us in a more human-like way and understand a little bit more, understand the context. And that's why we are adding more sensors to these devices to be able to perceive and sense the environment around them. And once you collect all this sensor data and you fuse them and all what needs to be done, you need to apply basically another layer of intelligence which can be based on machine learning or deep learning to understand the context of what's happening and what this sensor data means to the user or based on the application. And based on that, you can imagine many kinds of autonomous interaction that can happen. And maybe I would just start by a simple example for how that will apply to the smartphone, for instance. So now in your smartphone, you have the camera, and basically the use of the camera on the smartphone is one of the most interesting applications. Actually, one criteria that I used to purchase my current smartphone was the camera. So basically, one of the applications for that, if now the camera is your sensor, and you need to capture a great picture, in order for you to do that, basically you have to understand what you are trying to capture. So think about this scenario. If you are using the same camera to capture a soccer game, for instance, where there is lots of action, or you are trying to capture a scenic view, like a beach view or sunset, basically the camera will need very different settings. So if the camera understand what it's looking at, or understand the scene, knows if it's beach or say soccer or action game, it can adjust the lighting of the camera, it can adjust the shutter speed and many things automatically based on recognizing that. And that involves a lot of technologies related to, again, computer vision and machine learning. And that's actually why in MWC you may have heard about the Qualcomm DROS platform that we just launched. And that's basically this platform that have these three core technologies: very ultra low power sensor processing to get the information from sensors 24/7 without drying the battery or without draining the battery. And then also it has lots of capabilities when it comes to computer vision and how they're going to run in a power efficient way on this processor. And finally, deep learning capabilities. And we're going to talk about that a little bit more and what are the applications here.
So let me, I'll summarize. In a way, the growing amount of sensors on a smartphone, for example, the growing amount of data that a smartphone generates, you're pushing the intelligence to analyze what that is, what that means, to the edge or to the end device. Is that a correct summation?
That's very correct, actually, yeah. So one, actually, lots of innovation and time we spend is how to make these things work on device or on the edge. And there is actually a very important reason for that. We understand that you still need all your data analytics, all your intelligence on the cloud to process this data. But there are specific tasks or use cases that would actually lend themselves to being done on device or on the edge. So think about this scenario. Now in the area of ADAS for cars or autonomous cars in the future.
So that was ADAS for automotive.
So basically you need to run lots of computer vision algorithms. You need to run deep learning on the device to understand, basically to avoid collisions. So now if the car is autonomous, the car will drive itself and then it can avoid collisions. So now assuming you are on the freeway and then a moose is crossing, basically the car has to recognize that very fast. And by having all the analysis to be done now to recognize there is something and what is this thing and what I should do, if that is done in the cloud, it won't be acceptable from a latency standpoint. So for many mission-critical applications or when the data is generated on the device itself, it just makes more sense to do more of this local intelligence. And again, I guess doing a deep learning algorithm on a server or cloud, it's not an easy task, but doing it on the mobile device or in the car with all the power and thermal limitation, that requires lots of innovation from a hardware and software standpoint. Yeah.
Are most of these applications, and so actually there's a question from the woman in the back, so please go ahead.
You mentioned the sensors, right? There's a whole range categories of sensors that require different kind of processing. So the key here is some require intensive amount of processing and some don't. So how are you categorizing? Some sensors, it just has to turn on and off, mostly sleep, sending only kilobytes or nothing almost. Some entire data analytics. So what is your criteria for having all different range of sensors, and what is the current state of art of the processing power that you can handle that you think is realistic to put it into the inside of the sensors?
Yeah, so this is also, in a way, it sounds like a power management question. Is that correct?
It's more than power management, right?
Okay.
It's also what can you handle in the inside versus what can you play, and then also how are you going to combine all of them in different layers, because you're saying you need another layer for cognitive, some sort of control, right? Management. So.
Yeah, actually, that's a great question. Yeah. So again, I think it depends on what kind of sensors and what kind of use case you are trying to handle. Some of these use cases may lend themselves to be running on a big server on the cloud. But also even within the edge or the client, you are right, there are so many different sensors, and each sensor has many different requirements from performance and power standpoint. So for the sensors that really require basically low power, basically these sensors, you need to collect this data 24/7, and 24/7 meaning not continuously, but I guess with like small cycles. So basically you need really low power sensing engine within the SoC to handle that. And this is what we do with what we just announced, say, with our Snapdragon 820, the low power island DSP. It's a DSP architecture which is actually very capable in terms of compute, but also it runs very efficiently. And it has its own, in the architecture of the SoC, it has its own island and design that would keep this the power consumption low at this time. So that's an example of, say, some of these many sensors like accelerometers and motion sensors and pyrometers. All these kind of sensors would require this low power processing. But also now when you're a smartphone, you have a dozen of sensors today, so that require also more compute. And this is what we do on the low power island DSP. But think about another sensor, like the camera. Camera, at the end of the day, is a sensor that needs also to run in a power efficient way. and that can still be running in the SoC, but maybe it has its own dedicated engine, and we run stuff on GPU and DSP. So again, based on what kind of sensors, we handle that differently, for sure. And some of the stuff you can do on client, other things you just have to do it on cloud today. Yeah.
So I'll try and summarize, or at least the early use cases for this more in always-on devices. So the ADAS example, you're not power constrained, you need very low latency, you're attached to a big honking battery. So power management maybe isn't as much as an issue, but for others, where it needs to be somewhat always on, but maybe battery powered, are there some reference cases that you can speak to?
Yeah, sure, yeah. So yeah, actually the car scenario, actually it has its own also power, and surprisingly it has its own thermal requirements, but yeah, you cannot basically do that the same way, to your point, doing like processing information from an accelerometer or a motion sensor. So still there is lots of innovation that needs to go into this ADAS use case, but to run it in low power, but we have more room to do things. So we could be basically running it on a more capable engine if we need to do like computer vision or deep learning inside the car. Yeah.
So I'll lob an example, which I'm sure some folks in the room are interested in. You mentioned service robots or service robotics when we were during our preparation call. It's maybe a bursty use case where they wake up, they have to do something, but they're not active 24/7. So I was wondering if you could speak to that.
Yeah, so yeah, actually that's a great point, because again, you don't need to basically wake up the whole service robot or even the whole SoC when you think about hardware to do the service robot use case. So you almost, if you think about it, you need to run a very low power engine within the SoC or processor within the SoC that just wait for this wake up call. So in the case of service robot, like one of the use cases that actually one of the hotels in San Francisco is experimenting with is to have a service robot in the hotel that basically deliver personal items and food to the hotel guests, or a security guard. So that's a little bit more futuristic. But in this case, these service robots basically are sitting all the time doing nothing, but they have to listen to what's happening and know basically, now I need to do this. So that would have to be done in a very power efficient way, and you may turn on only a specific part, say of the SoC, that would deal with that. Once the service robot is basically functioning, maybe you turn on, you go to a higher power, higher performance processor and do more things on it. Yeah.
Sure. So another use case that I find particularly interesting is the drone use case. Obviously, drones, there's 20, 25 years of history, at least in the US, particularly in military applications, but we're at a point where drones are being used for filming, say for Mad Max. The chase scenes were apparently filmed via drone. So can you tell us a little bit about the use case for a UAV, for example, tower climbing, or a substitute for tower climbing, for example?
Yeah. So yeah, actually we see a trend here as we have been talking about drones, and I guess more in the agriculture and industrial application, military applications, but there is actually a trend that is driven by smartphones and mobile ecosystem in general, which is the consumerization of drones and robotics. So an example, flying camera, that can be actually used, again, for basically filming and more movie applications, but also can be used there is some ideas about how that's going to be the new ways to take selfies, like the follow me flying camera. And actually last month we announced the Snapdragon Flight 801 platform, that basically what it does is, now to build this kind of drone you need different boards, many boards to do it, and each board will have a specific function to do that. And what we have done, we integrated all of that in one basically board that is very small that you can put in the drone. And the implication of this is big, because this way you can get this flying drone that is typically very expensive to another level of price points. And also in terms of functionalities, like basically to take 4K pictures, you can do that on the drone, to do the collision avoidance, to do many things that the drone has to do as it navigates environment that now is becoming more possible on these things.
One of the use cases I find interesting for this is there's detection of a recognition of what's there. So essentially recognizing what a computer is, a camera is looking at, but there's also detecting what shouldn't be there, which is you've been you've been intruded upon. So I wanted to hear a little bit more about that use case.
Okay.
So it's more essentially a security use case.
Yeah. So basically, again, in the whole area of security and privacy, again, and if you see on that chart I have here on the slide, there are so many different applications to these cognitive technologies. One of them is actually security. And if you think about it, as hackers are getting more intelligent, and there are basically scary statistic that there is 1 million virus invented every single day. So we thought about it and we said there should be a more basically intelligent way to deal with this problem, and how can we use machine learning to deal with this problem, and how even we can do this machine learning on the device. And for us as Qualcomm, that made a lot of sense because we actually have access to the lower level stack of the device, from the hardware to the software layers. And to do security right, you really have to have this kind of access. When you combine that with machine learning, that becomes very powerful. And that's basically where we started to think about I can show you a little bit more information on that, yeah. Basically, we started to think about what can we do there. So in the area of malware, for instance, the way the malware is detected today is basically after malware is started to be recognized by anti-malware companies, it takes some time. They add a signature to this malware. The malware is a piece of code. You add a signature to it. Whenever this piece of code tries to access my smartphone the next time, the smartphone is going to block it. But there is work around that, or there are two other scenarios that this doesn't handle. One, how about the malware that the hackers just came up with today and started to hack into the devices? We call that unknown malware. And then there are other basically category of malware. It's called transformed malware. So the malware that has its own signature, and this is the piece of code, hackers somehow able to basically play with this signature and they change it. So now basically the smartphone or the anti-malware provider cannot recognize anymore. So now we are basically changing that by saying, yes, signature-based solutions are great. This is kind of the first firewall of protection that we're going to be using. And this is, you see basically here on the diagram, the blue line goes all the way. This is the good stuff. Then the first one is the signature-based. This is a malware that has been detected before. The signature-based solution is going to stop that. But for the transformed malware, it just comes and starts to do weird things. Examples of that. And that's actually a great example for using these cognitive technologies. So now I have my smartphone. My smartphone is on the table. The screen is off. Nothing is happening on my smartphone. And then this malware starts to basically mess up things and try to send an SMS on my behalf or take pictures. So basically from sensors data, we have the algorithm to know now the screen is off for sure and the device is on the table. I'm not holding the device. That can be done through motion sensors and some machine learning algorithm. And then, because now it's not moving, this is really abnormal behavior. Who is sending the SMS? And that's where the machine learning, or what we call machine learning-based behavior analysis algorithm, comes in and figure out, there is something abnormal here, and started to flag it and prevent it. So that's basically how we could deal with this malware issues in a new way.
One last question, then I want to make sure we get questions from the audience, but are you also getting into rules definition? So there's detecting the anomaly, recognizing this anomaly, but then there's what do you do about it? And are you going as far as saying, we, Qualcomm, will maybe set 20 reference rules for how to handle a given situation? Or are you really leaving that up to the end customer?
It depends on the scenario. So think about, we are using actually these technologies for malware, but also privacy violations. So you have all these applications basically that a flashlight application that all it does in life, it's just light. But basically it tries to ask for your contact list and upload your contact list to the cloud. And in this scenario, this is a privacy violation. So in some of these scenarios, we either decide to stop it or flag it to the user. So I guess the early release of the products would be flagging things that basically users are not aware of and flag it to them, and then users will have to deal with it. And also we are working basically with the anti-malware provider companies also to stop things when they don't make sense.
We're running out on time, so I want to make sure we take any and all questions that folks might have. Silence. All right, that's a little surprising given the subject matter. But okay, so I'll ask one last question, which is, we've talked about automotive, we've talked about drones, we've talked about security. Where are you seeing kind of the first traction, or I should say the first customer pull for an offering like this?
So basically, actually, we have been leading with the whole cognitive idea and machine learning. We have been leading with the security. Actually, it's interestingly enough, and there is a demand for that, but also there is a reason for that, because I guess all this idea of using deep learning and collecting lots of sensor data, basically people start to get not comfortable with the idea. Now my smartphone knows more about me than what I know or other devices. And that's why we think that security and protecting privacy should be the cornerstone of that. And that's actually where we're starting. So that's where we announced the Qualcomm Snapdragon Smart Protect actually first, yeah.
Yes, Derek.
So I think it's really interesting. Of course, Qualcomm is a company that wants to push its silicon and chips, and that makes sense. But is this a software-based solution that could be deployed on any platform that you're doing openly, or is this something that requires Snapdragon chips and platforms?
So basically, the solution for it to work really well, it's actually a combination of software and hardware. And there is a reason for that, because if this very intelligent algorithm run in software layers up in the stack, basically hackers can hack into it. So that's why we have our secure MSM that is basically a combination of software and hardware that isolate this intelligence from basically what hackers can do, yeah?
Thanks.
All right, well then, thank you so much, Magid, for a very interesting discussion. And